All right. For this one, what we're going to do is we're going to let u equal 2 to the x. So this one's a little bit different, but if you look here we have 2 to the x and we have 4 to the x, but we can change this 4 to 2 squared, so this becomes 2 to the 2x. All right, so that is why we're letting u be 2 to the x. Then what you're going to do is do your substitution, so we get 3u squared plus 4u plus 8. And for this one, looks like it's not going to be able to factor. So what we want to do is a quadratic formula. So u equals the opposite of b plus or minus b squared is 16 minus 4 times a times c all over 2 times a. But if you notice here, if you look at the discriminant, we have 16 minus 4 times 3 times 8, so that's minus 72. This is going to be a negative number, which tells me that this is an imaginary value. And so for this one, it turns out that there's going to be no solution. Okay, for the next few, 24, 25, and 26, we are going to solve them very similarly. And the issue we run into here is we have this negative x power. Okay, well that's not going to work so well in terms of solving because we want to kind of have it in this pattern where we have an exponent of 2x and x. Well, the best way to do that is to remove this 4 to the negative x, and we can do that by multiplying everything by 4 to the x. So we have 4 to the x times 4 to the x minus 10 times 4 to the negative x times 4 to the x equals 3 times 4 to the x. So what I did is I multiplied both sides by 4 to the x, but we had to distribute here because there were 2 terms, so that's why we have it twice. All right, now what happens here is anytime you have 2 of the same base, you add the exponents. So since the base is 4, the exponent is x plus x, which is just 2x. Okay, here same thing. We have 4 and 4, but negative x plus x is 0, and 4 to the 0 is 1, and 1 times 10 is just going to leave us with that negative 10. And then we have 3 times 4 to the x over here. Okay, so now we have it where it looks similar to quadratic, but we still need to set this equal to 0. So we get 4 to the 2x minus 3 times 4 to the x minus 10 equals 0. And then at this point, we can go ahead and let u equal 4 to the x. All right, so then what we want to do next is rewrite this. U squared minus 3u minus 10 equals 0. So we get u minus 5 and u plus 2. So u is 5 and u is negative 2. Now u again is 4 to the x. So 4 to the x equals 5. 4 to the x equals negative 2. But the issue here is that we know an exponential expression cannot equal a negative number. Right? 4 to the x, it's going to be all values above 0. We can solve this though. We want to solve for x. It's an exponential form. There's no easy number value, so I'm going to go ahead and change forms. So I have log. Here the base is 4, and logs equal the exponent x, and it's of 5. So then this is the exact answer. So we have log base 4 of 5. And then what we want to do is go ahead and plug that in. Oops. So log base 4 of 5. And then we get 1.161. All right, so again, this is very similar to number 24. We're going to solve it the same way. So what we're trying to do is we're trying to get rid of this 3 to the negative x. So we're going to multiply everything by 3 to the x power. And then we get 3 to the 2x minus, this cancels out, this becomes 3 to the 0, and that's 1, and 1 times 14 leaves us with 14. Now we want to get everything on the same side. And then we're going to go ahead and we're going to let u equal 3 to the x. So we get u squared minus 5u minus 14. So that's going to be u minus 7 and u plus 2. So u equals 7, u equals negative 2, which means 3 to the x equals 7. 3 to the x equals negative 2. We know that one doesn't work. And so I'm going to jump right to the exact answer here. We have log, the base here is 3 of 7 equals the exponent x. And then we're going to type this in. Again, if you have the other format, you need to do a change of base. So just go over that again. It's log of the number divided by log of the base. Or again, if you have this program, you can just type in 3 and 7. All right, so 1.771. All right, now 26 does look different, but it's actually very similar. What we're going to want to do first is remove the fraction by multiplying both sides by 2. So I'm going to multiply this side by 2 and this side by 2. And what happens is that'll go away. So we get e to the x minus e to the negative x equals 6. We're going to multiply everything by e to the x. So then we get e to the 2x minus, now this isn't 0, the exponent is 0, and e to the 0 is actually 1. And then get everything on one side. And then we're going to let u equal e to the x, so we get u squared minus 6u minus 1 equals 0. We're going to have to use the quadratic formula here. So we're going to have u equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Oops, a is 1. And then we get 6 plus or minus the square root 36. This is going to be plus 4, so that's 40 over 2. So that's 6 plus or minus, this is 4 times 10, squared 4 is 2. So then u equals, if we pull out a 2 from everything, we get 3 plus or minus root 10. Root 10 is more than the square root of 9, so 3 minus a number greater than 9 is negative. So, so I know that e to the x is only going to be 3 plus root 10. It's not going to be able to be 3 minus root 10. Once we get this, we can change forms. So I get log base e, which is the natural log, and then of the number is 3 plus root 10, and then that equals x. So we can just type this in, 3 plus root 10. Make sure to end the parentheses there, and then we get 1.818.